These videos are for March 2nd, March 7th. Today we're looking at solving rational equations and making sure that we understand when what we call extraneous solutions occur. So for here, we want to try to solve this equation for x, get x1. And in a lot of classes, what we talked about is we had similar issue when we did law of sines. We had equations similar like this. And the question was, how did we get x alone? What was a good thing to do initially to get really x out of our denominator to start? And what we talked about here is if we multiply here by x, multiply by x, then what we get is x out of our denominator. We would actually get this equation, x times sine of 57. And so ultimately we got everything out of our denominator and we could solve from here. So I posed the question in class, like how can we apply that concept to this equation here? Two things, I'm gonna solve it two different ways and then we can go from there. One student said, well, hey, we just learned how to add and subtract rationals. I'm gonna split this page in two parts. I'm gonna do it one way and see if we end up at the same place the other way. And so that student said, if we can get a comment, first off, we factored this factors as x minus 5, x plus 2. And then the student said, here we already have x minus 5 and x plus 2. Here we could get a common denominator. So I'm going to try to do that over here. We have x minus 5 plus 3x plus 2. And so they said if I give this side of our left-hand side of the equation x plus 2 by doing x plus 2 over x plus 2, this side x minus 5 over x minus 5 equals 7x over x minus 5 x plus 2. Then this denominator, if we did that, that denominator would become x plus 2, x minus 5. We would have to do distributive property here. So x times x would give us x squared. X times 2 would give us 2x. Over here, our denominator would be x plus 2, x minus 5. Again, distributive property, so we would have 3x minus 15. And now on the left-hand side, we have a common denominator, so we can go ahead and add those denominators, add the numerators. X squared, 2x plus 3x would give us 5x minus 15 all over x plus 2, x minus 5. X minus 5, x plus 2. And then we got here and we said, man, we still have these x's in our denominator. And we want to get them out. So what can we do? Well, similar thing here, right? We multiply both sides by x. That gets our x out of our denominator. Here, let's say we want to try to get the x plus 2, x minus 5 out of our denominator. We can multiply both sides by that. So we can write this as x plus 2, x minus 5, like over 1, if you will. Multiply this side by x plus 2, x minus 5. Multiply this side, I'm going to have to write smaller, x plus 2, x minus 5. Now hopefully we notice something. Here, we have an x plus 2 in our numerator, denominator. Those would go away. X minus 5s would go away. So all that we're left with on the left-hand side is x squared plus 5x minus 15 equals. On the right-hand side, similar thing. We have an x plus 2 and x plus 2. So these would divide out. X minus 5, man, same thing there. So on the right-hand side, now we just have 7x. And this is an equation that we know how to solve. I'm just going to subtract 7x from both sides to get 0. Since we have a quadratic on the left, maybe we can factor it and solve from there. Now we have an equation that we know how to solve by getting all of our x's out of the denominator. Now, I split this page into two parts. Hopefully you did that as well. Because what's happening is, what we talked about in class, we multiplied each side of our equation by something very particular. What I circled there. And when I asked this question, students said the denominator. That's true. We did multiply both sides by the denominator. But more specifically, what we're actually multiplying our equation both sides by is our common denominator. We had to find a common denominator initially, the x plus 2, x minus 5, then multiply both sides by our common denominator. So in class, what we talked about is, hey, what if we did that initially? What if we did that from the start? What if we said, I'm going to write this equation again, see if we end up in the same place. Sorry, I'm going to do this. What if we did x minus 5 plus 3, x plus 2. I'm writing small because I'm going to need space. 7x, x minus 5, x plus 2. And so essentially what we talked about is if we ignored this equal sign, if we wanted to add or subtract these three fractions, we can determine a common denominator from the start. So if we look here, our common denominator, this already has x minus 5 and x plus 2. This fraction would need x minus 5. This fraction would need x plus 2. So our common denominator would be x minus 5, x plus 2. So instead of getting a common denominator here and then multiplying, why not do it from the start? And that's what we did. So we said, if I multiply, I'm going to write the common denominator in red. X minus 5, x plus 2. Now, if I multiply this side, because I can do it on this side too, right? It's an equation. This is a little different from when we did adding, subtracting rationals, because that was an expression. So we have to multiply by 1, so not to change the value. Here, in equation, we can do whatever we want, as long as we do it to both sides. Now on the left-hand side, though, I'm multiplying everything on the left-hand side. So here, I would really have to do distributive property to both terms, because I have two terms split by this addition. So what happens is we have to multiply every term by this common denominator. So I have to multiply this by x minus 5, x plus 2 as well. Now hopefully we notice something. Here, if we look at this fraction here, we have an x minus 5, x minus 5. Those would go away. We can distribute our x here. X times x would give us x squared. X times 2 would give us 2x. Here in this term, x plus 2's go away. So now we can distribute the 3 to the x and the negative 5. So we would have plus 3x minus 15 equals, on the right-hand side, the x minus 5's go away and the x plus 2's go away, so that all that we're left with on the right-hand side is 7x. We can combine our like terms here. X squared plus 5x minus 15 equals 7x. Subtract 7x. And we actually end up in the same spot that we ended up with on the the other side. So the key piece here is we can find a common denominator initially, this common denominator. If we can find that initially, then maybe we can save ourselves some work by multiplying each term by that common denominator, getting everything out of our denominator to get to an equation that we know how to solve. Now from here, we can factor this quadratic and say x minus 5, x plus 3. You set that equal to 0 and solve, you would get x equals negative 3 and x equals 5. Now I'm going to pause here. On the next video, we'll talk about, these are seemingly our solutions. We're going to talk about how we determine if those are solutions or not by checking them, and also maybe not by checking them, and see how we can do that.